All right, today we are going to be stigging a Cisco switch. And the purpose of this video is to teach you how to stig a switch, hopefully without breaking everything.
We've got a long way to go.
Our primary focus today is going to be on actually configuring the switch, not necessarily hopping on Windows Server and configuring Network Policy Server or hopping into ICE. And as far as the scope goes, we're going to be going over the network device management portion of the STIG and the layer 2 switch portion. I will make another video at a later date with the router portion and show you how to configure .1x and set up radius on Windows Server. Prerequisites. If you're planning on doing this in an enterprise environment, you need to schedule downtime with your IT business partner or project manager. Whenever you stig things, you break things. And if you just walk into work tomorrow and decide that you're going to stig your whole environment, you're going to have a whole lot of very unhappy users. You need a Cisco switch. You need a console cable for whenever you're unable to SSH into your switch because you messed up radius. You need a local login to your switch for the same reason that you need a console cable. And you also need a local login to a PC near your switch. Because if you do something really stupid, you might be in a position where your domain computers aren't communicating back to your domain. All right, and on that same PC that you're going to have that local login to, you need PuTTY or a PuTTY alternative. All right, optional, STIG Viewer and the latest Cisco switch STIGs. You can get this on this website here. You can just Google STIG Viewer and you'll be able to navigate your way to that. And then also on my GitHub, I compiled all the notes for this so that you can just copy and paste and modify it so that it'll go a lot quicker as opposed to looking at the STIG Viewer and then copying and pasting from there. Not only that, but a lot of the stuff in the STIG Viewer is outdated. So whenever you try and copy and paste it, the commands won't take. So hopefully that will be useful to you. And before we get started, I need to assign a host name and some other things to my switch. So let's get on in it.
Let's get down to business to defeat the Huns.
All right, so we generated our keys so that we can SSH. We've given it a domain name and a host name. So let's go ahead and open this up, and we're going to start with network device management. And so what I've done is I've ripped out 28 of the 48 rules and made it so you can just drop it and copy and paste it in. The stuff that I put in the copy and paste section here is stuff that is going to have very minimal impact on your operation. So you can pretty safely drop this inside of your switch and you don't have to worry about knocking a whole bunch of users off the network. So that's what we're going to do first. We're going to grab this and we're just going to drop it in. So like I said, 28 of your 48 rules are going to be considered not a finding or good to go because you copy and paste and drop this in there. All right, so we just dropped all that in there, and let's go over what we just dropped in there. All right, so this portion right here is just enabling logging. This right here, this command locks you out of your switch for 15 minutes if you enter in the incorrect password 3 times within 2 minutes. So if you're planning on setting up radius and that's going to be part of your stigging, then I would recommend that you wait to put this in until the end whenever you're configuring radius. All right, service password encryption. This just makes sure that your passwords aren't in plain text. This IP HTTP stuff, I'll be honest, I've never managed a switch through a web GUI, so I don't really know what this does. I assume this just makes it so that it's HTTPS, that you can only have 2 people in the web GUI at once, and it makes you use radius to be able to access it as well. So you can throw this in there. You shouldn't be using a web GUI, but you know.
You should be ashamed of yourself.
I guess if you do, here's what the STIGs say to make it more secure. All right, here's our SSH commands. This is going to specify which encryption algorithms we use and that we want to use SSH version 2. All these commands right here, they're not going to do a whole lot to your infrastructure. I have heard that this will break Pixie Boot. I have put these on my switches and I haven't seen them break Pixie Boot, but every organization is a little bit different in how they do things. So just know that if things were working before you started stigging and then things are broken, that you might want to come and take a look in this area right here if it's a service like Pixie Boot. Okay, this right here is creating a password policy. This line right here, AAA authentication login console local, is just creating a login list that says that we're going to apply down in our line con 0 that says, hey, if you're logging in from the console cable or from that console port, that we're going to log in locally. We're not going to use AAA. We're not going to use Radius or any of those other things. All right. Here we have our login banner and message of the day banner. I think you're only required to have a login banner, but I put both just because it's nice to see it twice when the inspectors ask, hey, where's your banner? You can just, it's there. All right. Here's an extended access list that blocks ICMP. As far as I understand, extended access lists only work whenever they're applied to a VTY line. So I'm not sure why they want us to create this access list and then they don't specify that we're going to put it on our VTY lines, but you can create it. It'll make your inspector happy if he's just digging for something to find. And here's an actually important extended access list. You're going to apply this to your VTY lines, and then inside of this access list, you're going to put a subnet or a specific host that are going to be the only ones that are allowed to manage your switches or SSH into them. And then down here, we're going to close off all the VTY lines except for 0 and for 1. We're also going to put a timeout in there. And that way, only 2 people can be SSH into your switch at once. And then here we have that command that we were talking about earlier, the AAA login authentication console. This right here is just saying, like we mentioned earlier, that if you're logging in from the console, that it will be a local login, not using Radius. And what we have down here is an event manager applet, where essentially what you're doing is you're saying, hey, every time there is a configuration change, what we're going to do is we're going to TFTP a copy of the configuration to this IP address. So if you have TFTP set up in your organization and you have a TFTP server, this is really easy. You can just copy and paste this in. This is a little different than what the STIG tells you to do, but the outcome is the exact same. So I think the commands in the STIG Viewer are a little outdated. Switch name doesn't exist. It's router name now. And so you have to modify it a little bit, but this is really cool. Okay, now moving on. Now we're going to go over the things that are going to require you to have some information. So you can just copy and paste this, but there are other things that require you to have IPs on hand. So first thing we're going to do is we're going to set up logging. All right, and this switch right now doesn't even have an IP address assigned to it. So we're going to go in, create a layer 3 interface on this switch afterwards and make sure that all this stuff is working. All right, we're going to create our access list. All right, so with this command right here, we just said that, hey, if you are in the 192.168.1.0/24 subnet, then you are allowed to manage this switch. And if you're not, then you will not be allowed to SSH in. All right, and then here we go. And now we're going to need to assign a username and a password to the switch. And it's probably already done in your environment. I would imagine you already have a local login to your switch, but this right here is the only thing that's going to be different. We're applying the password policy that we set in the STIG commands that we copied and pasted. So I recommend you proceed with caution here. You don't want to change the password and then nobody know it. All right, and then now we need an NTP. So I'm going to set my computer as the NTP without all the security stuff because I currently don't have an NTP that's capable of that. And if it's the same way in your environment, then you're probably going to have to poem that portion if your inspector is not satisfied. So that is looking good. All right, I don't use SNMP here at home, so we're not going to put in any of these commands, and we're going to check this as non-applicable on this STIG. All right, Radius. I have already got Radius set up. So I'm going to go ahead and drop in my Radius server. We're also going to come in over here and make our Radius group. Drop these commands in there. This right here, we're saying that, hey, whenever you're authenticating via Radius, we want to have our source interface be VLAN 22, which is our management VLAN here in my lab environment. And then this command right here, we already went over the login console. And here we have AAA authentication login authentication group radius servers local. So let me explain exactly what all that means. Whenever you type in AAA authentication login, clearly that means that you are setting up how you're going to log into the switch. Okay, this is creating a custom list right here, this login authentication that we're going to apply to our VTY lines. And then we're saying, hey, we're going to use Radius And we're going to use this group that I just created down here called radius servers. And then that's going to reference all the radius servers that I put inside of the group. And then with this list right here, we're going to apply this to our VTY line. That way, anytime we log into the switch, it is looking for these radius servers right here to authenticate to. And then right here, we're basically saying, hey, if you log in either through radius or locally, you have all the privileges you need. All right, so now what we're going to do is we're going to create our layer 3 interface. We're going to make sure radius is working. We're going to make sure our TFTP backup is working. We're going to make sure that we're getting logs on our syslog server. All right, so now let's test radius. This is my username. All right, so we're in via radius, that's great. Let's make sure that our backups are happening properly. All right, so this just backed up at 509. It is currently 510. All right, cool. This is our whole config right here. That's great. Let's double check that we are getting logs. All right, we're getting plenty of logs. Scroll down here. This is the latest right here. It says last time this file was modified was 510, so that's great. So we're getting logs, radius is working, and our backup is working. So now what we're going to do is we're going to go ahead and take a look at our STIG viewer and make sure that everything looks good to go. This right here is not applicable. We have persistent logging enabled. This right here is not applicable. We have persistent logging enabled. We're not using SNMP, so this is not applicable. And all the rest of these are good to go. We went through every single one of these whenever we copied and pasted those commands. So we're officially complete with network device management. So now what we're going to do is we're going to pivot over to layer 2 switch portion. And so the very first thing that you want to do whenever you're doing the layer 2 switch portion, show interface status, include not connect. So we want to go ahead and shut down every single port that is not connected, assuming that these are user access ports. Now we're going to create VLAN 999, which is going to be our black hole VLAN. It's going to be a shutdown VLAN. We're going to shut down VLAN 1. Now we're going to create a new native VLAN. We're going to do VLAN 2000 because we no longer have 1 as our native VLAN. Now we're going to look at our switch. All right, so we only have these ports right here. These ports are all shut. They're not being used, so let's go ahead and shut these other ones. Just a quick note here, if your whole infrastructure is on VLAN 1, like I said, you're going to need downtime and this is going to take some careful planning before you just cut everything over. So keep that in mind. All right, so very first, it wants us to put in .1x, okay? You're safe to put this in there. It's not going to hurt anything if you're not currently using .1x, because .1x is applied on a per interface basis. So if your interfaces don't have .1x inside of them, then you're not going to end up knocking off a whole bunch of users. So we're just fine to put this in there. All right, VTP. You guys probably know what VTP is. VTP just makes it so that if you have a whole bunch of switches, instead of having to go into each individual one and make sure that it has all the VLANs that it needs, that it'll automatically send them down. So they want us to have a password on that. So that's what we just did. All right, QoS. There is a portion inside of the STIG viewer that talks about quality of service and wants you to put in like a whole bunch of access lists and stuff. But if you're on iOS higher than version 15, then that's already done inside the switch for you. So you don't have to worry about that. We're going to call that one good to go. All right, spanning tree, loop guard default. That just prevents spanning tree loops. All right, this is very, very important. So please pay attention. IP DHCP snooping and IP ARP inspection will take down an entire network if not implemented properly. So whenever you're getting prepared to do this, there are a couple things that you need to know. So DHCP snooping, basically what it does is it makes sure that there are not rogue DHCP servers on your network. And you do that by manually specifying where your trusted DHCP servers are. And on any other port that's not IP DHCP snooping trust, it will not be able to send out or reply to the request for an IP address. So what we want to do first is we want to identify where our DHCP server is and then track the path down to every single one of our switches where we have clients that are using DHCP. So I would find my DHCP server, and then from there I would track down to every single downstream switch. And then from the port where my DHCP server is, I would put IP DHCP snooping trust, and then I would put it on every single trunk port all the way down to the rest of my switches. Okay, and so you're only going to put that on your user VLANs, and then ARP inspection uses the database that's built by IP DHCP snooping. So you want to make sure that that database has been fully built before you implement IP ARP inspections. What I recommend doing, depending on how long your leases are for your network, leave DHCP snooping running for, I don't know. I mean, most people, I think the default whenever you set up a DHCP server is 8 days. Leave it running for 10 days and then have a test switch where you'll implement IP ARP inspection to make sure that it doesn't break everything, okay? All right, make sure you have spanning tree enabled. We already made sure that our, and just for clarity here, we're not doing IP DHCP snooping because we're not doing DHCP in this environment. But if you were, that's how you would implement it. We also aren't going to use ARP inspection because the ARP inspection is dependent upon DHCP snooping. So if everything's static, you don't need to implement these. It would be non-applicable. All right, so we already shut down VLAN 1. We created our black hole VLAN. We created our native VLAN. We've shut down all of our unused ports. And then here we go. Here are our host-facing interface commands that we have to add. So be very careful here. If you haven't set up .1x properly in your environment, your workstations don't have certs, your network policy server doesn't have the necessary configuration to check workstations for certs, you don't even know what ports your workstations are on, you might have printers in the mix, don't put this inside of your host-facing ports. You need to be very careful here because you will destroy your entire network if you try and throw on these .1x commands and you don't have it already set up. I'll make a separate video at another time on how to set up .1x using your Cisco switches and network policy server in an Active Directory environment. All right, so if you don't have .1x set up as a compensating control, you can implement port security like I just did right here. So you have to be careful with port security as well, because essentially what happens whenever you set up port security with MAC address sticky, only one MAC address will be allowed on that interface at a time. So if you have computers with phones connected as well, then I mean it's going to disable the port. So you can also make it so you can have 2 MAC addresses allowed, but this is only for host-facing ports. All right, IP verify source depends on the database that DHCP snooping builds, and switch port block unicast basically stops ARP traffic flooding out of interfaces if the MAC address isn't known. So be careful implementing this as well. I personally haven't seen this break a whole lot. If you already have your environment stood up, you can pretty safely throw this on interfaces, but I would test them on a couple before you do it. All right, spanning tree BPDU guard enable. So this needs to be on your host facing ports. Do not put this on your trunk ports, because spanning tree, as it sends out its messages to determine your topology, will send it down through your trunk ports where you have your, the same ports where you'd see your CDP neighbors, and it will error disable those ports if it sees any spanning tree messages. So make sure this is just on your access ports. All right, storm control. This is another one of those things that you need to pay attention for. So if you put the wrong number of zeros here, you will slow your network down to an absolute crawl. So the way that I have mine set up is I have them set up at the absolute max that the interface can handle. Essentially, it renders storm control useless. So you're going to have to figure out within your environment how much you can dial this back so that you're preventing broadcast and unicast storms, but also not slowing down your network to a crawl. So I recommend starting out, putting it at the max, and then every day you go in, just lower it just a little bit until you get to the point where everything's functioning properly still. Users' speed is not affected, but you're still able to limit those higher than average packet numbers that come in whenever you have unicast or broadcast storm. All right, and then for your trunks, you're going to have switch port. You're going to make sure you change to your new native VLAN. You're going to do switch port trunk allowed except VLAN 1, 99. And what that's going to do is going to make it so that VLAN 1 isn't being trunked down through all your switches. And it also makes sure that VLAN 999, that black hole VLAN.
I'm boring myself just talking about this.
Is also unable to pass traffic. And then we're going to make it so that the trunks don't negotiate, no negotiate, and then encapsulation .1Q as well. So let's go ahead and take a look at the layer 2 switch STIGs. All right, let's look at the red first. We're not doing IP ARP inspection because we don't have DHCP set up in our environment. This isn't used. This isn't used because it's also dependent upon the DHCP snooping database. All right, this is good to go. We made sure that VTP has a password. All right, and this is not good to go. We do not have .1x set up. So this is indeed a finding. It is a Cat 1, so that's a big deal. What you need to make sure that you do is communicate with your cyber team and have them POAM this item so that whenever you do get inspected, the inspector is already tracking that you don't have .1x set up and that you are using Sticky Mac as a compensating control and that you do have a timeline to get .1x implemented on your network. All right, we have root guard, we have BPDU. And if we were to go line by line, all the rest of these would be good too, minus the ones that are non-applicable and .1x. And I look forward to making that video for you guys, and I hope that this video was helpful to you, and I hope that as you're stigging your stuff you'll be aware of some of the gotchas and that this will be a resource for you to implement STIGs in your network without breaking everything. Good luck guys, I believe in you.